Exercise 9.1 Problem 3 Solution. Draw a circle of diameter 10 cm from a point P 13 cm away from its center. Draw two tangents PA and PB to the circle and measure their lengths. Okay, so we'll have to take a point 13 cm away from its center and we'll have to draw two tangents PA and PB to the circle and measure their lengths. So let's draw a rough diagram. So with O as a center and 5 centimeters radius, you're drawing a circle. Then from O, you are marking a point P away from it 13 centimeter. So OP equal to 13 centimeter. So what else here? Now we'll have to draw two tangents. So two tangents from P will be something like this, PA and PB. Okay, which will touch this point, extreme point. And what we are asked to measure the length of the tangents. Okay, so with that in mind, let's do the construction. With O as a center, we are drawing a radius. Sorry, with O as a center and with a radius of 5 centimeter, we are drawing a circle. Right? So that's what we are doing. With O as a center and radius as 5 centimeter, we are drawing a circle and marking these two radius. Right? Next, with O, we are marking a point P, which is 13 centimeters away from O. With a scale, you measure 13 centimeters and mark this point P. That's done. Next, what we do, we have to find the perpendicular bisector of O and P. How will you find the perpendicular bisector? With O as a center and radius which is greater than half of OP. Okay, it has to be greater than half of OP, or maybe 60 or 70%, but it has to be greater than half of OP. Draw two arcs here and here. Similarly, with the same radius, with P as a center, draw two more arcs. And these two arcs will cut each other and join the point of intersection. So that is how you'll be able to get a perpendicular bisector of OP. Let me repeat, with O as a center and with radius which is greater than half of OP, that is, which should be greater than 6.5 centimeters. Half of 13 is 6.5 centimeters. So let's take 8 centimeters. You draw these two arcs. With P as a center and with the same radius of 8 centimeters, cut these two. So these two arcs intersect each other at 2 points. So join these two intersecting points, and that is nothing but is a perpendicular bisector of OP. And let's name it as M. Now with M as a center and MO as a radius, draw a circle. It will touch both O and P. Now it is intersecting the first circle at 2 points, right? Let's name them A and B. You join PA and PB. And PA and PB are nothing but the tangents from P to the circle, original circle. So PA and PB are nothing but, this is what we are asked to draw, is the tangent of the first circle, okay, from the external point P, from point P. Okay, now if you measure this, let's measure this, and this happens to be, and if you have done it correctly, it will come to 12 centimeters. Okay, so let me repeat. What did we do? With O as a center, you are drawing a circle of radius 5 centimeter. Okay, and from O, you are marking a point P 13 centimeters away using a scale. Now, what you do? You are drawing a perpendicular bisector of OP. How did you do? 13 centimeter, half of it is 6.5. So let's take a radius which is greater than 6.5 centimeters. As I said, let's take a radius of 8 centimeters. With O as a center and 8 centimeters as a radius, you're cutting two arcs. This one and this one. With P as a center and the same 8 centimeters as a radius, you're cutting two more arcs. One above, one below. Both will intersect the first one at 2 points. So both the two pairs of arcs will be intersecting each other. Join those 2 points, and that is your perpendicular bisector. Okay. Now let's say it cuts the perpendicular bisector cuts OP at particular point M. Now with M as a center and MO as a radius, draw a circle. MO and MP will be equal, right? With M as a center and MO as a radius, draw another circle. So it will it will pass through O and P. Now this circle will intersect this circle at point A and point B. join PA and join PB. That is nothing but PA and PB are the two tangents of this circle from this external point. And you measure that PA and PB, it will be 12 centimeters if you have done it correctly. Okay, right. Now let's go through the construction. So what does it say? With O as a center, you're drawing a circle of radius 5 centimeter. You got it? So this is the first step. Mark a point P, which is at a distance of 13 centimeter. Draw a perpendicular bisector of OP. So this is the perpendicular bisector. I explained how to do it. Then with M as a center and MO as a radius, draw a circle. With M as a center and MO as a radius, you have to draw this circle. Then these two circles intersect at this point A and point B. Join PA and PB. So these P and PP are the required tangents. You measure it, it will come 12 centimeter if you have done it correctly. Okay. Now we'll have to verify this. Let's do a verification. See, this tangent means OA and PA are perpendicular to each other, right? So OAP is a right angled triangle. Am I right? OAP is a right angled triangle because tangent is perpendicular to radius. Now in a right triangle, what is it? The square of the hypotenuse, that is OP square, is equal to sum of the squares of the other two sides. So OP square will be equal to OA square plus PA square, right? That's what it is. Now what do we want to do? We want to measure PA, right? So what is PA here? So PA square will be OP square minus OA square, or PA will be square root of OP square minus OA square. And what is OP square? 13 square, because OP is 13, so OP square is 13. And OA square is the radius, that is 5. So OA square is 5 square. Now this is 169 minus 25. 169 minus 25 is 144, and square root of 144 is 12 centimeter. You got it? When you measured it, also you got the same 12 centimeter. So this is how this problem needs to be done. Please pause the video here and try to work this problem, okay, on yourself. Then only you will get practice. Okay, practice is a key for construction. Thanks for watching this video.